Let's look at a second derivative example, but to find the second derivative, I need to find the first derivative first, so I'll use the product rule here, okay? So product rule using these two pieces that I just labeled. Let me call f to be 3z squared. I guess you can factor out the 3 to the front, but I'll just go ahead and use it. Okay, I'll just go ahead and use 3z squared. F prime is 6z. G is ez, e to the z power. Well, then the derivative of that is going to be just e to the z power. Okay, so I got my 4 pieces labeled. I am about to do the product rule. The first derivative of w with respect to z, or w prime, is going to go like this. First times the derivative of the second. What's that? The derivative of the second is easy. Okay, e to the z power plus second times another easy coming in, and we're multiplying this by the derivative of the first, which is 6z. All right, let's simplify this. Okay, you know I've been usually factoring out this exponential term, right? So let me factor out this e to the z power. Okay, to the front, what's left inside then? We have 3z squared plus 6z left inside. So that's the first derivative. Let me now find the second derivative of this. I think I can just use product rule again, okay? Because take a look. I can call f to be my e to the z power, right? Making that to be the first piece of the multiplication. Well, then the derivative of that is e to the z. How about we call g to be this parenthesis? What's inside is 3z squared plus 6z. And then I'll say g prime is going to be 6z plus 6, right? All right, we're ready to do the second derivative. What is the second derivative of w with respect to z? We have to do the product rule again, right? First times the derivative of the second plus second times the derivative of the first. So what's the first in this case? The first is ez. So I'll say e to the z first. And I'm multiplying this by the derivative of the second. That's what g prime is. 6z plus 6 added by, what's next? I need to do g prime. I'm sorry, it's just g. So that right there. 3z squared plus 6z. And let's multiply this by f prime, which is ez. I think we're done. We just have to simplify this now. What kind of terms can we factor out? I would like to factor out this exponential term to the front. So what's left inside? This is left inside, 6z plus 6. And from the second, we have this 3z squared plus 6z. As you can see, we can simplify this inside part. I'll write this one first, 3z squared. But if I add this 6z and another 6z, that's going to be 12z and plus 6. Well, I think I'll factor out the 3 now, because everything can be divisible by 3. So my answer will be 3ez times z squared plus 4z plus 2. I don't think there is any number that multiplies to be 2 and add up to 4. So this is where I will stop in terms of simplifying using factoring. So double derivative problem, now the second derivative problem, ended up using product rule twice. Wow. But everything else is really review of everything that we learned in module 1. The only new idea here is that when you took the derivative of e to the z, that it was simply e to the z. So that is really the only new piece of the lesson in this in section 2.2. But everything else just really just things are piling up, right? the product rule, simplifying algebra and all. I'm gonna stop this video and I'll try to record this equation of tangent line in another separate video.